In this video, I'm going to show you how to do exponential equations for grade 11 level. The golden rule for exponential equations is that a to the x is equal to a to the y only if a is the same. This means that the base on both sides of the equation needs to be the same base. The key here is to get the bases into a product of its prime factors, as in an exponential form. So let's start with examples to show you how to do these. 3 to the power of 2x equals 27 to the x minus 4, and we have to solve for x. So this is an exponential equation because the variable in the equation is in the exponent. So the first step is to convert everything to the same base, which will be a base that's a prime factor. So 3 is obviously a prime factor, so we leave it. 27 can be converted into a prime factor. Unsurprisingly, it would be 3 to the power of 3, the same base as the other side. We keep what's on the outside. In the next step, we can times that out, so 3 to the 2x. From law of exponents, when timesing an exponent into a bracket, when the exponent is in a bracket as well, we times them together. So it becomes 3 times x minus 4. At this point, because the bases are the same on both sides, we can simply equate the exponents, because what we have now is this situation. So we kind of drop the bases and we make the exponents equal. So we can put therefore, and we just make the exponents equal. 2x equals the other exponent, 3x minus 4. And now we solve as if it's a normal equation. So 2x equals 3x minus 12. If we had to take that 12 over to the other side, it would be 12 equals, and let's take the 2x over to the other side, 3x minus 2 would be x. So that's your answer. And you can check yourself. On your calculator, you can substitute x on the one side, get the answer, substitute x on the other side to get the other answer, and see if they equal. If they equal, this answer is correct. Okay, let's try another one. 3 to the 7x minus 3 equals 9 to the 2x. So the 3 on the left-hand side is fine because it's already in its base. So we can leave it as it is, 3 to the 7x minus 3. The 9 needs to be converted into a prime base, which would be 3 squared. We keep that 2x on the outside. In our next step, we can neaten that up by getting rid of those brackets. So it becomes 3 to the 4x. Now the bases on both sides are equal. We can drop the bases and make the exponents equal. Bring the 4x over, becomes 3x. Take the negative 3 over, becomes 3. Divide by 3 on both sides. Therefore, x is equal to 1. And again, you can check this by substituting it in on the one side, getting an answer, doing the same for the other side. And if this is correct, both answers will be equal. 2 more examples. 4 to the 2x equals, all rooted, 8 to the 2x minus 10. This one is slightly trickier. We have to still get our bases the same as prime factor bases. So 4 needs to be converted into 2 squared. Don't forget what's on the outside there, 2 to the x equals, what a half means, what root means is to the power of a half. So we can change that to the power of a half. So 8 to the 2x minus 10 to the power of a half. You should remember this from other sections in maths. So 2 to the 4x equals, I'm going to use a square bracket now because we have to convert this 8 into a product of its prime bases, which would be 2 to the 3. And keep everything that's still there, and it's still to the power of a half. Let's neaten this up. 2 to the 4x equals 2 to the 3 times 2x minus 10 to the half. You can of course skip a step like this and go straight from this step to the step I'm going to do if you are able to see the maths in your head. 2 to the 4x equals 2. Now we're going to times out this 6x minus 30 to the power of a half. Our next step will be to get rid of this bracket on the right hand side by timesing in that half. 2 to the 4x equals 2. Half of 6x would be 3x. Half of 30, 15. So minus 15. Our bases are now the same on both sides and they are prime numbers. Therefore we can now equate the exponents. 4x equals 3x minus 15. X is equal to minus 15. And that's your answer. Let's move on to our final example. 3 to the x plus 1 plus 3 to the x minus 2 plus 3 to the x equals 1, 1, 1. So the way we do this is that we have to, because there's plus signs in between each of the terms, we have to break up these 3 to the powers into single exponents. So 3 to the x plus 1 becomes 3 to the x times 3 to the 1, because 3 to the x times 3 to the 1 is the same as 3 to the x plus 1. We're just breaking it down into single exponents. Plus 3 to the x times 3 to the negative 2 plus 3 to the x is equal to 1, 1, 1. What you can see now is that in each of these terms there's a common 3 to the x. So we can take that out as a common factor. You will often find that when there's these plus signs between terms or minus signs in questions like this, that it will lead to some kind of factorization. So be on the lookout for that. So 3 to the x is our common factor, and then we're left with 3 plus 3 to the negative 2 plus 1 equals 1, 1, 1. What we do now is we want to get 3 to the x by itself. So we can divide both sides by this big bracket. This you can do on your calculator. And when you do that, 3 to the x equals to 27. Then we have a simple exponential equation, and we can break up that right hand side into a product of prime factors, which is 3 to the 3. Our bases are the same, so we can equate the exponents. X equals 3.